There's a part of the quadratic formula we got to get cleaned up. Okay, so I've set everything up for you. GCF, no. 6, can't find factors that add to 9. That's 7, that's 5. Factoring doesn't work, go to your quadratic formula. So the opposite of B is negative 9. Then B is 9, A is 2, C is 3, A is 2. Plus minus, you got negative 9, 2 times 2 is 4. Now plug in the radical. Even if it's an irrational number, it's better than a domain error. Okay, I got an irrational number, but at least it's not an imaginary number, 7.55. Now don't stop there. Since you didn't have to use the I, you do not stop. You go negative 9, you add and divide. Negative 0.36. Then you subtract and divide. Negative 4.14. Okay, next problem. Opposite of B, negative 4. B is 4. A is 5. C is 8. A is 5. Negative 4, 2 times 5 is 10. Plug in the radical. Domain error. When you get a domain error, you put the radical there and you plug that in to your calculator without the radical. It's a real simple concept. Okay, negative 144. Now that means I poke the I out. I'm not allowed to add and divide or subtract and divide, but I do want that radical simplified. Well, that's an easy one to simplify. 144 is on the board, okay? It's 12. So I don't make 2 square roots. I just put 12 with the I on the end, okay? So now rewrite it. So negative 4, 12I over 10. You can write that answer, but you can't add, divide. You can't subtract, divide with the I there. One plus, one minus. Okay. Now an alternative method to write that, you could break that up into negative 4/10 plus or minus 12I over 10. That could reduce by a factor of 2, so it'd be negative 2/5. Factor of 2, 6I over 5. So you have negative 2/5 plus 6I over 5, negative 2/5 minus 6I over 5. That's an alternative way to write the answer. I'm guessing not many are going to choose it. That's fine. Okay, next one. Opposite of B, negative 6. B is 6, 4, A is 3, C is 7, A is 3. So you got negative 6. 2 times 3 is 6. Plug in the radical. Domain error again. So you write the radical down. And you plug in the expression without the radical. Negative 48. Poke the I out, so we're not going to add, divide, subtract, divide. I do want the radical simplified. Now, unlike the last problem, it ain't on the board. So if it's not on the board, you make 2 radicals with the I there. It goes in between. Now start dividing by perfect squares. You'd start with 36. That's the first perfect square that's smaller than 48. 16, 3. Put 16 in the first, 3 in the second, and then you replace the square root of 16 with its equal, which is 4. Now rewrite it. 4I square root 3 over 6. So okay, an alternative method, you could just break them up. Negative 6 over 6 plus or minus, and then 4I square root of 3 over 6. That's negative 1 whole. The 4 and the 6 get reduced. The 3 doesn't do anything, okay? So that's 2, that's 3. 2I square root 3 over 3. So negative 1 plus 2I square root 3 over 3. Negative 1 minus 2I square root 3 over 3. Those could be the solutions. Okay, next one, same idea, opposite B, negative 7, 7, A6, C is 4, A6. Negative 7, 2 times 1 is 2, second square root, 7 to the second, minus 4, 6, and 4. Domain error, now plug it in without the radical. Negative 47, okay? So you put the radical down, poke the I out. You can't add and divide or subtract and divide like you could on the very first problem, but I do want equals. I want the radical broken down with the I in between. So 47, we'd start at 36 again. 25, nope. 16, nope. 9, nope. 4, nope. Heck, I'll do 1. What the heck? 1 and 47. Square root of 1's 1. Okay. Negative 7, it'd be 1I square root of 47 over 2. Okay. Not much you'd be able to do there. You'd have negative if you did it the other way. Okay. 1I square root of 47 over 2. I would keep that. You wouldn't be able to reduce it. It doesn't divide whole. And then 1 over 2 is in simplest form too. And you write the thing with the plus, the thing with the minus. Okay.